Alright guys, we're now looking at target 3B, arc length and area of sectors. And we're going to start with arc length. So our master learning objective is I can find the length of an arc by setting up an equation to calculate a portion of the circumference of a circle. So the first thing we're going to look at is some of our vocabulary. Circumference is first. We've talked about circumference. Remember, the circumference is the whole way around the circle, or the whole distance around a circle. And the circumference is the formula for circumference equals 2 times pi times r, or 2 pi r. Okay. An arc we have not really talked about yet. An arc is a portion of the circumference. So right here they have this arc. So a portion of the circumference. And so any piece of the circumference really there. Then we have what we call arc measure. And the measure of your arc, if I can talk, the measure of your arc is the angle, really. The measure of the, what we call the central angle. And that just means the vertex is at the center. That creates the arc. So all that means is, if you notice, right here's the center of my angle. If I go out, right, I cut into my circle, and that creates this piece, right, the starting and the stopping point of that piece. And this angle is the same as that's the measure of the arc. Okay, so the measure of the arc, and now what we're going to look at, the arc length, are two different things. So then we have the arc length. The arc length is the distance of the arc. Okay, so this is measured in inches, feet, meters, etc. Okay, for this one, our measure, it's an angle, so it's measured in degrees, radians, right, which we kind of talked about. Okay, so the measure of the arc is an angle. The length of the arc is what you would actually think of, like you can measure it with like a ruler, or like we did with a piece of string. Okay. So how do we find the arc length? Well, the arc length is a portion of your circumference. So if we take our circumference and we're going to multiply it by whatever that fraction is, and we find that fraction by the angle over 360. Okay, so if it was 60 degrees, it'd be 60 over 360, that fraction of the circle times the entire circle. Okay. So let's look at example 1. Find the length of the darkened arc. Okay. So the easier way, the arc length equals what we would call theta, your angle, over 360 degrees, right? So the part over the whole, times your circumference, which is 2 pi r. My angle for this one is 315, right? He's telling me this angle. Divided by 360 degrees. Times 2 pi, and then we have our r, which in this case, right, is here, which is 11. And to find this, I really just want to type it all in my calculator. Here. So, you can get this fraction if it makes more sense to you that way. All right, so this is 7/8 of our circumference, and our circumference is 22 pi. Okay, so this whole portion of the circle here is 7/8 of the whole circle, and the whole circle is 22 pi. Okay, so now when I type this part in my calculator, I'm going to do 7/8 times 22. I'm not going to worry about the pi right now. And I get 77. We go put the pi on top. Fourths, and this is in feet. This is how we write an exact answer for that. So the pi goes with your numerator, technically how we write that. If you write 77/4 and then pi off to the side, that's fine. It's just kind of a standardization thing. Looking at our second one, the only difference with this one is now this is 3 pi over 2. This is in radians. So the only thing that's going to change, that is our length equals. Now when I do theta, my whole circle is, I'm not going to use 360 degrees because I'm not in degrees. Remember, 2 pi radians makes up a circle times 2 pi r. So my theta is 3 pi over 2. Right, that comes from here. That's my angle. Divided by 2 pi. Times 2 pi. My radius here is 16. So then, I'm going to do this part first. The first thing I see is that these pi's are going to cross out. You should be able to see that. Pi divided by pi. So I have 3/2 divided by 2. And that does give us 3/4. And you should kind of be able to see that this, we're finding 3/4 of our circle, times 2 times 16 is 32 pi. And 3/4 times 32 is 24 pi. Right, we just write the pi down, and this is also in feet. Okay. So if your angle is in degrees, your work looks like this, right, with the 360 degrees. If your angle is in radians, then you have a 2 pi on bottom. Okay. All right, go ahead, turn the page. The next thing we're going to look at is some word problems. Example 3 says the windshield wiper of a car is 24 inches long. In one sweep, it turns through an angle of 115 degrees. How far does the tip of the wiper blade travel? I know this is an arc length problem because it's asking me how far something travels, so that's a distance. Equals, right, theta over, I know it's going to be 360 because this is in degrees times 2 pi r. You don't always have to make a drawing, but sometimes I like to. Just usually draw a fan shape. You can think about the rest of the circle comes down, but technically most of your real world problems, they don't create a full, it's things that don't create a full circle. If you think about the windshield wiper in your car, it doesn't completely make a full circle. Okay, it's 24 inches long and it's going through an angle of 115 degrees. So I know my angle, right? My angle is 115, coming from here, over 360, times 2 pi, and then our radius, right, since that was the tip of our wiper blade was 24 inches, 24. Okay. Technically, I don't need to split anything up in my calculator. I can type this in all at the same time. I have 115 divided by 360 times 2 times 24, right? The only thing I don't type in my calculator is that pi. And we get 46 over 3. And the pi goes with the numerator. 46 pi over 3, and this is in inches. So the word problems are just the same. There's just not a picture for you, but you're still just pulling out the angle and the radius. All right, looking at example 4. A person standing on the earth notices that a 747 jumbo jet flying overhead subtends an angle of 0.45 degrees. That's very small. If the length of the jet is 230 feet, find its altitude to the nearest 1,000 feet. So, it's, right, if you think about the earth, right, looks like that. This is like, would be like the path of the jet. You're standing somewhere, you look up, and this, we're gonna say this is 0.45 degrees. The length of the jet is 230, so that's up here. Here's my beautiful plane. I'm trying to draw a plane. And we're trying to find x, how high above it is. So my arc length equals theta for 360 degrees times 2 pi r. So my arc length, we actually know it's 230 feet. We don't need the feet. 230. My angle is 0.45 degrees over 360 degrees times 2 pi. And it's actually my radius that we don't know, that x there. Okay. So this is a little bit different problem. This is like when you're solving for the radius or the height of the, when we had volume problems, we knew the volume, right? Solve for the radius or the height there. So the first thing I'm going to do is I'm going to simplify the right side. I have a lot of things over here. So I am going to do 0.45 divided by 360 times 2. And I get this very small number, and that is okay. That 0.45 is so small, 0.0025. So 230 equals 0.0025 pi times x. And all I'm doing here is solving for x. It's a multiplication problem, so I'm going to divide. So I'm multiplying by, or dividing by 0.0025 pi on both sides. Okay. When you are using your calculator with pi, I do actually have to type the pi in this time because I'm dividing by it. It's only when multiplying we don't. We have to be careful because you have to put this division in parentheses. So 0.0025 pi has to be in parentheses. Otherwise, if it's not in parentheses, I'm just going to write it up here. It would do 230 divided by 0.0025 times pi. And that's not what we want, right? I want the pi to also be in the denominator. So if you're ever dividing by pi, make sure it's in parentheses with what you're dividing by. And we get about 29,284.5. And that makes sense. It's a jet flying. They fly very high. Okay. All right. We have two example 4s. So again, example 4. So now we're looking at a car tire has a 14-inch radius. What angle has the wheel rotated if the car moves 2 feet? Okay. Well, as I move along, right, that 2 feet, I'm actually moving the wheel 2 feet this way, okay, because tires rotate. And I say 24 inches because this is in inches, so we would need to do, right, 2 feet times 12 inches per 1 foot equals 24 feet. So sometimes we do have to change our units. So this is going to be 20. What is the angle? Okay. So now when I set up my problem, I have arc length equals our angle over 360 times 2 pi r. I have a different set of things. I know my arc length is 24. Now I don't know theta times, right, but I know my radius. So again, I'm going to simplify this by just multiplying the 2 times the 14. 28 pi. The first thing I'm going to do is divide by 28 pi. So again, since I'm dividing by pi, I'm going to do 24 divided by, in parentheses, 28 pi. And we get 0.2728. Equals, right, these cancel out, so I'm left with theta over 360. And now that I have this, I have my angle divided by something, so I'm just going to multiply. So I'll take what I have in my calculator and multiply it by 360, and I get 98.2. Now we're looking for the angle, so that's 98.2 degrees. All right, the last problem we are looking at is example 5. A measuring wheel is used to calculate the length of a path. The diameter of the wheel is 8 inches. The wheel makes 87 complete revolutions along the length of the path. To the nearest tenth of a foot, how long is the path? So here's my measuring wheel. If you ever see them like pushing a cart type thing along. That's a lot of times what they're doing. They're measuring. People who like install fences have them, or a lot of those like landscaping, construction. They can just walk it along and it will measure how far they've moved. Okay. So the diameter is 8. That means my radius, and I'm going to do it going up, is 4, is half that. Okay, so the wheel makes 87 complete revolutions. Okay, so for, to how long is the path. So this is still an arc length problem. But instead of an angle, we're given how many times it spins. If it went half, we'd measure by 1/2. But we made 87 revolutions times our circumference. I guess I will make that a little more generic. It's number of revolutions times your circumference. So in this case, right, we have 87 revolutions times, and our radius is 4, right? Because it was the diameter. Now here, it wants it to the nearest 1/10 of a foot. So I am going to type pi in my calculator. With multiplication, I don't have to worry about putting in parentheses. You can if you want. Parentheses don't ever really hurt. They only help. Okay. So we have 2,186.6. Inches. Now I need to get it to the nearest 1/10 of a foot. Times 1 foot over 12 inches. So I'm going to divide that number by 12. And I get 182.2. Sorry, this video was a little bit longer, but I will see you guys Tuesday.